You always be saying that. Okay, why is it so Jimmy really sucks?
All right.
Hey, Mr. Brand,
Yes.
was the teacher meeting the other day like planned or was it an emergency?
It was a teacher meeting that we were told to go to.
Okay.
So
Winter in Wisconsin can be cold.
this is what they were supposed to show you yesterday in home base, ladies and gentlemen, and I hope your teachers did. But if they didn't, I'm going over it because just so you know, these will be enforced starting on Monday. Okay. Oops. Sorry.
Can I hit it?
There you go. Dress appropriately to stay warm at school. Winter coats can be worn outside when you enter the school. They are to be put in your backpack or your locker. Every one of you has a locker. It is an infinite campus with the combination. I don't want to hear you don't know where it is. That's on you. Find it then. Okay? But backpack or your jackets, outdoor jackets are not allowed in the class anymore starting on Monday. Okay? And you cannot bring blankets either. Okay? Ski masks can be worn outside, but when you enter school, they are to be put in a backpack or your locker. Medical masks are available at the security desk. Okay? This is the school board policy, not Green Bay East policy, the school board policy that says that you cannot wear jackets in school because it is a safety concern for the things that can be stolen or hidden in them. Okay? Headgear must allow the face to be visible except for clothing or headgear worn for religious or medical purposes. Okay? So this is what they consider to be appropriate layers, ladies and gentlemen. Sweatshirts. Sweatshirts. No jackets, sweatshirts. Okay? You want to come in with 3 sweatshirts on, you are welcome to. Okay? Jackets stay in your locker or in your backpack, or if you would like, you can leave them out in the hall. I don't care. One of those 3. Okay? So, no blankets, no coats, no puffy coats, no face masks. Questions? Good. Wonderful. All right, ladies and gentlemen, get your computers out, open them up. This is what we are going to be doing today. But here's your question of the day. Would you rather be stuck watching Hallmark movies all weekend or listening to country music all weekend?
Who are we listening to?
It's a random country music station that you are listening to.
I can't look at your country. Is it like do that from?
Ooh, a little bit of both. Little bit of both. Here's the thing. This is not a hard decision, ladies and gentlemen. If you're even worried about what country music it is, you're not on the right side of this decision. I can tell you that right now.
I like Hallmark movies.
Really?
I see some of these, and then I
like to watch them.
My wife gets mad at me every time she watches a Hallmark movie because I tell her how it's going to end when it begins. And I'm right every single time.
But the drama is like me. It's always a girl moves away from a small town and the guy stayed and then she moves back with the bad guys and they end up reconnecting.
No. A lot of times they're opening an inn or a.
Oh, you're right. Yeah, she reopens like a hotel or a bakery or a bakery, and then they reconnect and then they fall back in love.
All of those things. Correct. And about 20 minutes right before the end of the show, they break up, and then they get back together and kiss, and it's over. Okay? Wonderful. Yes, sir.
The Christmas Hallmark movies is always a prince.
Yes. Apparently, there's a lot of princes in the world.
Are you a prince?
I'm not even a frog.
Oh, you're a prince of my heart, Michelle.
That scares me more than you'll ever know, sir.
No.
Yeah, on Monday your jacket has to stay in your locker. And
What's the difference between wearing 3 sweatshirts and a jacket?
here's the thing, you shouldn't need to wear 3 sweatshirts. I teach in here 8 hours every day in a short sleeve shirt.
Yeah, I'm anemic, okay, so I get very cold.
Okay, then bring a sweatshirt. It should be plenty warm enough for you. You don't wear that jacket outside in May when it's 70 degrees outside, and that's the temperature it is in here. Yes, it is. I can show you a thermometer if
I
you
do
like.
wear jackets outside in the spring.
Not the heavy winter ones.
98.6. 98.6.
Huh?
Okay, it's a
Um,
I have not done anything in Illinois for 2 weeks, and I gotta do it a week. I hate meal deprivation.
Oh, that guy.
All right, ladies and gentlemen, let me get attendance here.
Is that why he's getting away all night?
Dude.
Bonus questions, right?
I was trying to walk towards the ride.
Dude, I'm gonna put that in my presentation, slip it about Illinois.
I mean, you can look in your, I think
That's
your
right.
transcript.
3, 4, 5. Let's get to this side of the story.
All right. First of all, 3 reminders, ladies and gentlemen. Well, actually 2, because the retake 2 part of this is basically done today. Missing work and retakes for Unit 3. If you scored less than a 70% on the Unit 3 test and you want to do a retake, needs to be done by next week, Thursday, ladies and gentlemen, and I will not be staying after school on next week, Thursday, so you got Monday, Tuesday, Wednesday to do it. Okay? Questions? I am here every morning. You can come in during home base. You can come in during a prep hour or an hour that you have a study hall and do a retake, ladies and gentlemen. But remember, you need to bring me your test with corrections made first. Are there any questions on that?
No.
Wonderful. Okay. Then let's go back to where we left off yesterday, ladies and gentlemen. Yesterday at the end of the hour, I had done this to balance a chemical equation. Now, what I want you to realize, I cannot leave this 6.5 in here. However, because of these diatomic molecules, these 7 compounds that are O2, H2, N2, Cl2, Br2, I2, they will a lot of times be alone in a chemical reaction. And you will need to put a number in front of them. But obviously, because there is a 2 there, you can't get to odd numbers. You can't get to 13. You can't get to 15. You can't get to 7. You can, in this one case, put a 0.5 number in front to get to an odd number of them, because that does get this balanced. Putting a 6.5 there means that you have 13 oxygens on that side, ladies and gentlemen, and that is balanced. However, you cannot leave it this way. And the way we get rid of this 0.5 is we go through and we double all of the coefficients. Now, one of the things I did not mention yesterday, when you do a balanced equation, just like when you write an ionic compound, there are a lot of ways to get them to balance, because once you get it balanced, you could multiply everything by 2, by 3, by 4, by 5, by 20 if you wanted. And it will stay balanced. But just like with ionic compounds, a balanced chemical equation needs to be in its lowest terms. Okay? Now, if you start out with small numbers, you should not end up having to reduce things. Okay? You should not end up having to reduce things. But if you have 2, 2, 2, and 4, yeah, you should reduce that. If those are your coefficients, 3 2s and a 4, they can all be divided by 2. In this case, we used the 0.5 to get it to balance, and that is fine. And the way we will get rid of this 0.5, ladies and gentlemen, is we will double everything. So we will make it 2. We will make it 13. We will make it 8, and we will make it 10. Which of these 4 numbers do you think people normally forget to double? The 2. They forget that there was a 1 in front because there was no number there, because we don't write 1s. And they will double the 6.5 to 13. They will double the 4 to 8. They will double the 5 to 10. They will forget to double the 1 to 2. Please do not forget to do that. Okay? Now, I would never, never, never use a decimal other than a half. Don't get into thirds. Don't get into quarters. Nothing like that. I simply use a half when I have a diatomic molecule to get it to balance, ladies and gentlemen. Questions? All right. So let's take a look at our next one, ladies and gentlemen. By the way, just to show you, 8 carbons, 20 hydrogens, 26 oxygens over here. When we double it, we have 8 carbons over here. We have 16 carbons here, or I'm sorry, 20 hydrogens here. We have 16 hydrogens here, and 16 oxygens here, 10 oxygens there. That's how we get our 26, ladies and gentlemen. So when you double everything, if it was balanced originally, it will stay balanced for you. You do not have to worry about rechecking it. Questions? All right. Okay. So now, ladies and gentlemen, let's take a look at this one. For this, ladies and gentlemen, I have already taken and written down all of your elements that are involved in the compound. Aluminum, nitrogen, oxygen, sodium, chromium. We do not list oxygen twice, even though it is in 2 places. And this is what I mean, ladies and gentlemen, about oxygen having the ability to be all over the place. So if you were to try to balance this by doing oxygen first, ladies and gentlemen, it would be a disaster for you. It really would. Why? Because there are a lot of ways of changing the amount of oxygen in this reaction. So one of the rules I said was to start with elements that there is only one way to balance. Okay? What I mean by that, ladies and gentlemen, let me bring this up real quick here. What I mean by that is when you look at these, some of these, there are only one way to balance them, ladies and gentlemen. So for example, the chromium. There is 3 on one side and 1 on the other. There is only one thing that you can do to get that balanced, which is to do what? What do we have to do to get that to balance, ladies and gentlemen? Declan, go ahead. Okay, double which? Which side needs more? Okay, so you want me to put a 2 in front over here on the left?
In front of the AL? Is that what we're doing?
We were talking about chromium here.
Oh.
I picked chromium. All right? Why? Because there's only one way to get it to balance. It's a 3 over here. It's a 1 over here. What do I got to put in front here? KP? A 3. So I'm going to put a 3 in front of this compound here. That is the only way I will get chromium to balance. Now it becomes 3. But I need to go through, ladies and gentlemen, and I need to double check everything that I changed. I also changed the sodium to how many? 6. I changed the oxygen here to how many oxygens in this compound? Nope. Try again. There are 12 oxygens in here now. Why? The 3 times the 4 gives me 12. How many oxygens are in this compound, which I didn't do anything with? There are 9 here. But that is the only way I could tally this up, ladies and gentlemen, is to add up those 2 spots together to get 21. Now, I am not going to try to balance oxygen still. In the end, if you do everything else, oxygen will have to be balanced. So I'm not going to worry about oxygen in this. Now, next you can either balance aluminum, nitrogen, or sodium. Which one do you want to do? Okay, so to balance the aluminum, what do I need to put over here? Because the reactant side is lacking aluminum. It only has 1, the other side has 2. What do I put in front here? Put a 2 here. That changes the number of aluminums to 2. Now, how does that affect the number of nitrogens? Thank you. It becomes 6. Okay? And we also change the amount of oxygen. So instead of 9 oxygens in this compound, there are now how many? 18. Very good. Okay? And 18 and 12 is 30. So you are occasionally going to get to some large numbers, ladies and gentlemen. Michaela, what can I do for you?
That was 21, not 12.
That was 21, not 12. What was 21? Can I?
You said 30.
Oh.
You said 18 plus 12.
Okay, but remember, I don't care what the number was before. It was 21 before because there was 9 here and 12 here, correct? That totaled up to 21. Now, by putting the 2 in front here, I have 18 here, correct? And I still have the 12 here. So when I add those together, that's how I get this 30. Does that make sense? Yeah, and that's something that people look at and go, well, wait, we changed that to 18, so shouldn't we add 18 to the number that we originally had, 21? No, because part of that 18 was already in there. Does that make sense? Okay. When you get a minute, Michaela, please put your headphones away. Thank you. Okay, so now I got 3 things left to balance. Nitrogen, sodium, and oxygen. Well, all of those are together over here. So what number do I got to put in front over here to get either nitrogen or sodium to balance? I put a 6 there. Okay? Because now there are how many sodiums? How many nitrogens? 6. Now, let's do a little bit of adding up. There are 18 oxygens here. How many oxygens are in this compound here? 12. For a total of? Works out every time, ladies and gentlemen. It works out every single time. Questions? Now, in reality, ladies and gentlemen, in reality, when I work a problem like this, I don't even bother to add up the oxygens. If I get these 4 other things to balance, the oxygen has to balance. It has to. No ifs, no ands, no buts. Okay? The only way it would not balance is if you somehow wrote a wrong formula. Okay? And on these, I'm giving you all the formulas. So in reality, if you want to save time, don't even worry about doing the oxygen here. Do all of the other things, but you can only do this because oxygen is in every single compound. Okay? Because it's in every single compound, in the end, it has to balance out. So you don't need to waste your time adding them up as you're going through. Balance the other things. Questions? Now again, here's a case of where, we used 2s and 3s, but we needed a little bigger number there to balance off the sodium and the nitrogen. That is going to happen occasionally. Questions? All right, so here we go, ladies and gentlemen. Our last one to practice together. Okay, let me clear this stuff off. There we go. All right, again, we added it up already. 1 phosphorus on the reactant side, 1 on the product side. 3 chlorines on the reactant side, 1 on the product side. 2 hydrogens on the reactant side, 4 hydrogens on the product side. 1 oxygen on the reactant, 1 on the product. Okay? Where do you want to begin? Which one do you want to begin balancing, ladies and gentlemen? Somebody pick one for me. CL? Okay. So what do I got to do to get the CL to balance? Okay, I can't get rid of them. You can't. What are you going to do? Destroy them? Come on, you can't do that. Which side needs more chlorine? Reactant or product? Okay, so here's chlorine on the product side. What number do I got to put in front of that compound? Let's put a 3 in front of it. Okay? So now we've got 3 chlorines. What else did we change, though? Okay? Hydrogens. How many hydrogens here? So wait a minute. How come we're going down with hydrogens? We had 4. Now we're going down to 3. There's how many now?
7?
No.
6.
That's where you got to be careful. Okay? You are good to notice that, okay, there's other hydrogens here. But because we switched this to 3, we don't just add 3 to this number. one of them was already in here. So we have to do 3 hydrogens here, 3 hydrogens here. That totals up to be 6. Okay. I think that's what, Michaela, you were referring to a minute ago too, when I went from 21 to 30. Why did I do that? You got to add them up in both spots again. Okay. All right. How many oxygens now? 3. All right. You want to balance out hydrogen or you want to balance out oxygen? You tell me. Okay. Hydrogen. Here's hydrogen on the reactant side. It's the side we are lacking hydrogen. What number do I put in front? How many hydrogens? 6. How many oxygens? There you go, ladies and gentlemen. You have a balanced chemical equation. Questions?
Thank you.
All right. Questions, ladies and gentlemen? Okay. Now, I'm going to introduce you to 3 types of reactions today, and then I'm going to give you some time to balance some chemical equations to practice it. Again, I don't care if you work in groups of 2. I don't care if you get in a group of 4 at the back. I don't care if you get in a group of 20 and do it. All right? But here's the thing. You got to figure out how you can balance chemical equations, because you are going to need to do it in this unit. You are going to need to do it in Unit 7. You're going to need to do it in Unit 6. You're going to need to do it in Unit 5. Well, maybe not so much in 5. Okay? So, with that in mind, ladies and gentlemen, there are 4 types of chemical equations. There are more than 4 types. There are 4 types that we're going to talk about in this class. The first of them is what is called a synthesis reaction, ladies and gentlemen. A synthesis reaction is when you take 2 things, 2 substances. Now, what is a substance? A what or a what? Element or a compound. Okay? So on each side of a chemical equation, you've either got elements or compounds, ladies and gentlemen. A synthesis reaction is when you take 2 substances, either elements or compounds, and you put them together and you make only one thing. Okay? A reaction in which 2 or more reactants create only one product. That is the definition of a synthesis reaction. That is the definition of a synthesis reaction, ladies and gentlemen. Okay? Now, when you were in physical science, if you were in physical science, and if you had me, how many of you had me as a teacher? Yep. Remember the high school dance?
Yep.
The snowfall dance? Mm-hmm. You're looking like you don't remember, Katie.
I remember it, I just don't like it.
Okay, well, the snowfall dance is an imaginary dance that I make up every year, ladies and gentlemen, about a high school where I teach you how chemical reactions happen. So let's talk about a synthesis reaction. So I completely make this up, ladies and gentlemen. But there is this boy, say, named Dante, who, oh, that's right, I forgot, you're Dante, who wants to go to the dance, but he doesn't have a date. So he goes on his own to the dance. And at the dance, he sees a girl from chemistry class. They both have chemistry class together with Mr. Brain. And he goes up to this girl. Her name is KP. Okay? And he says, hey, do you understand the chemistry homework that Mr. Brain gave us for the weekend? And she's like, yeah, it's easy. I can help you with it. There's absolutely no problem with that at all. And he says, thank you so very much. That's great. And she asks him, well, would you like to dance since we're here? And they start dancing and they have a wonderful time. And they become a couple. Now, while this is a different kind of chemistry, ladies and gentlemen, this is a representation of a synthesis reaction. We take 2 lone elements, we combine them, and we make them into a compound. Okay? Completely fictional story. Completely fictional. Okay? The general formula of a synthesis reaction is A plus BC. It could be A plus B. In the example of the high school dance, it was a metal plus a nonmetal making an ionic compound. Okay? Now, these are the easiest reactions to identify. Why? Because there is only one product. There is no plus sign after the arrow. Anytime you have a reaction where there is no plus sign after the arrow, it has to be synthesis. It cannot possibly be anything else. Has to be synthesis. Questions? Go ahead. Well, see, means yes, I have a question. Means no, I don't. Okay, good. All right.
We're not talking about double replacement?
Not yet.
Slow down, Declan.
Double
Yep.
replacement was my favorite one.
All right. Anyone need more time with this slide? No, we're good. Okay. The exact opposite of a synthesis reaction, ladies and gentlemen, is what is called a decomposition reaction. A decomposition reaction is a reaction in which one reactant, one compound, it has to be a compound. Why? An element cannot break apart. So it has to be a compound. Breaks into two or more products. Might be two things, might be three things, could even be four or five. Those don't happen very often. But it is possible for one thing to break down into two or more things. Okay? Now, our last one had a general formula of A plus BC produces ABC. This has a general formula of ABC breaks apart into A plus BC. Okay? Now, again, making this up, completely up. Okay? Totally fictional. Well, we had the story of Dante and KP, who were our synthesis reaction. The dance didn't go so well for a boy named Mason. See, there's a boy named Mason who was dating a girl named Lucy, and they were going to the dance together. Okay? And what Mason didn't realize is the night before the dance, the new Call of Duty 37 Kill 'Em All came out. Big Call of Duty fan. He's in line waiting for that at midnight for it to come out. He goes to the store, he buys it, he goes home and he starts gaming. And I guess there's this thing now where you could play against other people even if they're not in your home or something like that. What?
Online gaming.
He is playing for so long, his phone literally dies. One of his friends finally says, hey, look, I got to go because the snowfall dance is tonight and it started 20 minutes ago. And Mason is like, what? Because, see, he was supposed to pick up Lucy at 6 o'clock and take her to dinner and take her to the dance. So he's now an hour and a half late picking her up. But luckily, when he gets there, he tells Lucy the story of how his grandma fell down the stairs when she was carrying her groceries up the 3 flights of stairs to her apartment, and how he had to carry her up the stairs, put her in her apartment, put away all her groceries, and that was why he was late. Okay? So she forgives him. They get to the dance. He gets there. He's like, can I take your coat? He goes to put her coat away. She's standing there with a group of her girlfriends who are telling her how nice she looks because she had her hair done and her makeup done and everything. None of which did Mason mention, by the way. Okay? And Mason runs into some of his buddies who were there, and he starts talking about the online gaming he was doing the night before. So needless to say, he's gone for about another 35, 40 minutes. When he gets back, what he doesn't know is that one of Lucy's friends said, yeah, well, let me back up a little bit. Lucy was telling a story about this wonderful Mason and what he did for his grandma. And somebody said, really? Because I heard from Isaiah that he was online gaming until like 7:30 that night. And then they realized what had happened. And Mason makes the mistake of coming back to a group of girls huddled up together, group of young ladies huddled up together. And all he gets is a bunch of fingers in his face going, you are out of here. Which is okay, because he goes home and he plays more Call of Duty. But he goes home alone, Lucy goes home alone. What have we experienced, ladies and gentlemen? A decomposition reaction. A decomposition reaction. We had a compound, we've now broken it up into the pieces that make it up. Now, just like we identify a single replacement or a synthesis reaction by no plus sign after the arrow, we identify decomposition as no plus sign before the arrow. Questions? Okay, please get this copied into your notes. Then we got one more story today, ladies and gentlemen.
Yay.
One more story.
Who's it gonna be this time?
I'm making up these names, Dante. I don't know what you're talking about.
I feel like you have like a sheet of names that you just go.
I just randomly, they pop into my head and I go with them. Okay? Pop into my head and I go with them.
Okay, that's believable.
Okay? Questions? We good?
Mm-hmm.
Okay, now we're ready, ladies and gentlemen, for our single replacement reaction. Now, in a single replacement reaction, you have two substances on each side of the reaction. But when you have these two substances, ladies and gentlemen, one of them is an element and one of them is a compound. So it is a reaction in which a single element takes the place of another element in a compound, creating a new element and a new compound. So on both sides of the reaction, you have an element and a compound. Okay, you have an element and a compound. Here's the general formula. A plus BC produces AC plus B. Okay? I think this example was written down for you, wasn't it?
Yep.
Okay, good, because I didn't want you having to format everything and stuff like that. Okay? Okay, so now I got one more story about this dance, ladies and gentlemen. One more for today. And it's the story of a girl named Michaela. Okay? Michaela, it doesn't matter because this Michaela has another friend named Michaela. It's the weirdest thing ever. Okay? So this Michaela, okay, is going to go to the dance with this boy she really likes named Isaiah. So Michaela and Isaiah are going to the dance together. Now, Isaiah didn't make any of the mistakes that Mason made. He picked her up on time. He had a flower for her, did pictures with the families, okay? All that stuff was good. Went to dinner, had a good time, got to the dance, okay? Got to the dance, okay? And at the dance, okay? At the dance, they're having a good time. They're having a good time. But Michaela sees her friend Michaela. So she goes over to Michaela. Isaiah goes to the bathroom. Michaela is talking to Michaela, and at the end of the conversation, Michaela accidentally spills punch on the other Michaela. So Michaela's like, oh, I got to go clean this up. So she says, do me a favor. When you see Isaiah, tell him what happened. Michaela's like, not a problem. Not a problem at all. So Michaela goes to the bathroom to get cleaned up. Isaiah comes out. He's looking for Michaela. He sees the other Michaela. He goes up. He's like, hey, where's Michaela? She goes, weirdest thing. She just left 5 minutes ago. What do you mean she left 5 minutes ago? Yeah, she said she wasn't here with anybody. That she just wanted to get out of here and wanted to go home. I think she said something about going playing Call of Duty. All right? Isaiah's devastated. He's like, well, I thought we were having such a good time. And Michaela sees this and she's like, you know what? You don't deserve that, Michaela. She is
That's
not right
exactly
for
what
you.
you did.
Not right for you. Do you want to go somewhere and you want to talk about this? And they went somewhere and they talked about it. And Isaiah found that he had a lot in common with the other Michaela too. And they started dating. That was a single replacement reaction. We replaced one Michaela with another Michaela and made a new compound. Okay? So that's a single replacement reaction. I realize that one gets a little confusing because they're two Michaelas, but they spell their name differently, so it's okay. Okay?
And the superior.
You got the Michaela and the Michaela.
The Michaela and the Muck. I wish you would have said that. I didn't even think about changing the names like that. That would have been so much better. Anyway, ladies and gentlemen, the real chemistry. Well, not the real chemistry, but it was interesting in class the next Monday when all three of them got together in the same class again, let me tell you. Okay, how do you identify it? You have to look for an element and a compound. Got to look for an element and a compound on both sides of the reaction. That is the only way that you could tell if it's a single replacement reaction. Have to have an element and a compound on both sides of the reaction. How do we recognize an element? One capital letter. How do we recognize a compound? Two or more capital letters. I hope these fictional stories help you remember some of this and keep it straight somewhere down the line, ladies and gentlemen. Questions?
Where'd you get the inspiration for the two Michaelas?
I've been doing this story for years and names just pop into my head. I don't know where they come from. I really don't.
You should become an author. You're a really good storyteller.
Really? I've thought about that, but I can't write worth a darn. I'm
You just gotta
definitely
have
an audio storyteller. I'm not.
How
a-
about you just say it and someone types it up for you?
Yeah, you just gotta have somebody.
See, that seems like a lot of work. Seems like a lot of work. I'm happy being a teacher. It's okay. I get to make these stories up, and you know.
Happy being a teacher.
I've never heard anyone say that.
What?
I'm happy being a teacher.
Well, if I wasn't, I sure wouldn't be doing it for as many years as I've been doing it.
Mr. Fisk is my favorite author. He made a book. It's like the fishing guide or
You know
whatever.
who my favorite author is?
$20 an Amazon.
Mr. Mills.
Actually,
It's in my. I could probably bring it up.
what's his first name?
Brian.
Brian Fisk. We don't look.
You choose, okay.
He's my voice teacher.
Okay,
That's
now,
one
real
year
quick,
my-
ladies and gentlemen, before you start breaking up and going into groups and balancing these,
I'd never break up.
can someone find me a synthesis reaction on this list? Give me the number of a reaction that is a synthesis reaction where you only have one product.
Oh, number 9.
Okay, number 9, ladies and gentlemen, on the third page is a synthesis reaction. You have sodium and bromine coming together to make sodium bromide. Okay? Can you find me another?
Number 15.
Number 15?
Never mind.
Okay, wait. 15's not synthesis. What's 15 though?
Oh,
15 is a decomposition. Again, no plus sign before the arrow there. Okay? All right. Anyone else able to find me another synthesis or decomposition? I don't see one either. I don't see one either. All right. How about a single replacement? How about a single replacement reaction? Now you need 2 things on each side. One of them has to be an element. One of them has to be a compound.
Number. No.
4?
Number 16.
Which one?
4?
4 is a single replacement reaction, ladies and gentlemen. Number 4 is a single replacement reaction. Iron on the reactant side is an element. HCl is a compound. On the product side, FeCl3 is the compound, and H2 is the element. Michaela, you said which one, I think?
16.
16. Let me find it. Yes, 16. Copper is the element on one side. Silver nitrate is the compound on the reactant side. On the product, you've got copper nitrate as the compound and silver as the lone element. Okay? Good. Any others?
7.
7. Yep, 7. HCl, compound, zinc, lone element. Product side, zinc and chlorine, compound, hydrogen, lone element. Any others? 14. Yep. Yep. Good. Good. Questions? All right. So what I'm going to do, ladies and gentlemen, is you have got basically a half an hour here. Okay? Get as many of these done as you can. Now, you cannot complete the ones that are after number 20. Okay? But what you can do with the ones that are after number 20 is you can start writing the compounds. Okay? So an aqueous solution of aluminum nitrate reacts with an aqueous solution of sodium hydroxide. Well, you should be able to write those 2 compounds on the reactant side here. To produce or to form a precipitate of aluminum hydroxide and some sodium nitrate that is dissolved in water. So that one, you should be able to make every compound that is there. You should be able to write it out, and after you write it out, you should be able to balance it. The same for the one after that, because it tells you all of the things that are involved in it. Okay? Yep. Actually, you can do them all. You can do them all, ladies and gentlemen. Okay? Now, the ones at the end, You need to write the formulas for it, but we have done that. If you have questions on anything, raise your hand, let me know. I don't care if you want to get in bigger groups and go back and work at the lab tables. You want to pull some desks together. You want to work on it on your own, that is 100% your choice, ladies and gentlemen. But I will tell you, you will find it a lot easier to work with somebody else so that you can run things by them if you get caught. Go to work, ladies and gentlemen, and if you need something, please let me know. I will be happy to help you, ladies and gentlemen. Go to work. Go ahead. Oh, you know what? Michaela, you guys work together. I just realized that just dawned on me that when I told that story, you guys, never mind. Never mind.
That's crazy.
Crazy. Crazy.
Mr. Slaughter, you want to go in the back? I remember it was it was kind of fun.
You do a few of the balancing, you're like, yeah, this is easy, got this down. Jump to the ones at the end. Jump to the ones where you have to write the formulas.
One, right?
Oh, I know
Which
you're
one did you start with?
asking me for
And then you also change the oxygen and the hydrogen.
Monopoly Go. On XVPN.
Yeah.
Then the oxygen on that. The oxygen, on the oxygen,
I'm pretty sure this one was like in Velvet. I don't know if it was
This no.
I have to stay one day. I'm not here how another 2 months.
Yeah, what's all 3 rounds? The guy. I think I have one of those. I think we have a balance bar or something. What is? So here. It's like the cats. And like the Cats movie or whatever. The musical. Cats. You have to Cats movie.
So you gotta like.
I wonder about balance.
Did anyone here ever watch Cats the Musical 2016?
I saw it.
What was it about?
Like the musical?
The movie, whatever.
It's about singing.
That's what it's really.
Yeah, that's why I said it was. No, I haven't. I don't watch movies. I just can't sit down. Oh, I do. But it was in the background when I was playing the movie. I don't know.
I'm watching it on Sunday.
I didn't actually like watch or play any of those games. The movie was great.
Not though. I would watch my friend play. So I don't understand. No, literally, like I tried. Like I tried like watching.
All I know is that don't watch games. They just make up a bunch. I don't know. I keep Felix Morales knows a lot about it. Just keeps liking it. Do you have an applicant that Washington?
Yeah.
I don't know. He also apparently likes the winter time as well.
Because sulfur dioxide should have.
So the other triangles.
It's oxide.
Oh.
So how many oxygen?
Send me that, John.
Yes. Sulfur trioxide gas decomposed. This is where you should put the sulfur trioxide. That's supposed to be sulfur dioxide. So again, binary compound. Binary compound. What is the formula for sulfur trioxide? Okay, that's what I'm telling you. Your compounds are not correct. So I can't get it to
Yeah.
I'm sorry, I didn't hear you. I'm sorry. I wasn't ignoring you. Blame Michaela because I had left the door open for you and she closed it when she came in. She's like the heck with Rose.
You mean Jimmy?
I don't think it. Oh, arrow there. Sorry.
For number 17, ladies and gentlemen, there is a typo on it. For number 17, there is a typo. The arrow should be after the calcium bicarbonate, the HCO3 with the 2 around it. The arrow should be there, and there should be a plus sign where the arrow is. It's breaking up into 3 things. So for 17, please adjust that. Right after the first compound, the arrow should be there, where that first plus sign is, and there should be a plus sign where the arrow is. So it should be one thing breaking apart into 3 things. Sorry. Sorry about that. All right. Let's see what you got.
Charges. There are no charges when you use the prefix. You're trying to balance a -2 with a -2. You can't balance a -2 with a -2. There's a negative. This one is supposed to be sulfur dioxide. Okay, here's what I would tell you.
It spells about.
Not myself.
Over here. That's a good trick. If you're at the end like that, you're like, okay, why aren't they down? You missed something. Yes, so what that means. When you accept the inside for well, no, CL is separate from the outside. Down here, we're breaking everything up. What it's with up here. I want to know how many of them are on here. What did I do? So, again, for CL, the oxygen, there are 6 here. 2 here and 1 here. Are you actually not, we're not using a lot. This one? This oxygen. Everything else to balance. If you want to check out, why do you like it? I was not saying that. Oh, I remember that. I remember that. Oh, Alexander. Oh, oh, never mind. Well, this ain't it. It was. Somebody fixed it. Okay, I'm ready. Oh. Yeah, no, I remember I was going to oh, yeah. Oh, see, here's like I kind of miss.
I'm not talking about that one person.
You see this? You earned there for the rest of you see this?
Yeah, I think it's something.
Why can't
That's correct.
Did it really take you that long to figure out what I said? You must love He tried talking to me the other day during lunch, and I don't know him. I don't know why he knows my name. That's really weird.
I don't think there was a CI or.
Johnny was sick.
Yeah, there's no CI.
He said, Johnny said that he read it on the Jewish.
I know, that's. We're gonna do it. Well, I'll get you.
So,
You know it's bad when I'm sick. No, you are making me being around you. Your heart's fast.
Question.
oh, yeah.
Okay. Never did that.
That was an accident.
I'm putting this away. That's what we know what's in.
You don't want to spend $7 on the phone.
Okay.
It's not $40. Isaiah's not laughing because you're funny. He's laughing because he's sick of
How do you feel about you?
you. I don't care. You tell me. You can't blame me for your loss. You can't blame me. 72 hours. You better see me back to where you're on. It's not funny. You're laughing at your own joke. It's not funny. Yeah. There's a vitamin 83 where like there's I don't know why it's called the vitamin 87. It's not vitamin 83. So I think William Afton's son. I was like, have an animatronic in 83. Wait, hold on. So now,
Let's no. You change.
yeah, no, so there's the vitamin 83. Yeah. Oh, yeah. No, there's like 2 bites.
Number to that. Yes.
The vitamin 83 was like a kid, they're being published. Crying child. That was 83, and then the vitamin 87 was Toya Fine, a security guard from Fort Worth. That was the vitamin 87.
You can't just put a number or something and say, well, I'm gonna add that amount to it. You have to recalculate. What's that now?
No. Was really in every.
I don't know why I did that.
I don't either.
Oh, wait,
Now,
that's right.
because
I did
in this problem, I'm gonna ignore it to the end once I get. So let's balance the height of it. What number over here? Minus 2. Jasmine, can you grab one of those sheets? Oh, that's the balancing that we're doing right This is where you keep track of how many you have. Now, why did you put a 3 there? That's crazy.
All 3.
Well, she counted up the height, she counted up the oxygen. She made it wrong, but she counted up the oxygen. This is basic. This is basic.
Mason. Why didn't my grandson?
Why? How many oxygen? How many oxygen are here? What's 3 and 4? Well, she did not do that because I told her you didn't have to worry about it.
No, that's not.
I don't need help.
I'm so good.
Oh, wait, the bell's about to ring. I didn't.
Yes.
Come over here.
Again, why are you wasting your time?
I don't know if you don't
But it's time to pass.
Only when it's in every spot in the park. Have a great weekend, ladies and gentlemen.
Why does she hate you guys so much?
She hates us so much.
Miss Emily.
Oh no, nobody hates you guys. Nobody hates you guys. What? I would never admit that to any of you.
That's.
Okay, but theoretically, if you were to hate someone who's your
What? I am going to plead the fifth.
it's a hypothetical situation.
Hypothetically,
Are we going to
I hate
Everybody.
Antoine
Are we going to?
because he's the hypothetical student that I would have in there.
That was light.
That was lame.
I know you're not talking about lame right now, Ab.
I know you're not.
Listen, Brad, are we going to there?